Hello everyone, I'm Prabhat, and today I'm going to talk about big data analysis in sports. What is big data analysis, how it can be implemented in sports, and I'll take examples from my own research, and I'll show you how we can have better understanding of sports performance or how we can predict sports performance using big data analysis and even machine learning. So, what is big data analysis? Big data analysis is often a very complex process where we use mathematics or statistical tools to analyze very large volume of data, which can uncover information such as hidden patterns, correlation that will aid in a more reliable and meaningful insights into making decisions. It can also be used to build technologies and services that can be cost effective or even develop services that were previously not available. So, how is big data analysis important in sports? It is primarily important for providing performance evaluation. For example, we can use in-game performance records of athletes or a team, and we can extract physiological and biomechanical data using laboratory experiments. And we can give them feedback regarding how their performance is improving, analyze any risks of injuries, or help them in rehabilitation. These data can be used by team managers and coaches during the purchase of players or even during training to see how they can enhance the performance of athletes. The performance evaluation can also be done for general population. For example, we can use wearable device to track performance of general people during various sports activities. This data would allow us to give very important feedback to the users regarding how their performance is progressing, which might encourage people to participate more in sports. We can even use this data to analyze the sports participation habit of a very large population in specific areas. And we can understand how is the sports participation rate changing in those areas or how it is different from different areas or different countries. And we can use this to develop policies for people to participate more in sports and generally live a more healthier lifestyle. Another area of sports where big data analysis is used is in the development of new technologies for sports. For example, for smaller and more cost-effective wearable technologies, which can track performance, requires very machine learning-based models, machine learning or deep learning-based models, using large volumes of data to increase its reliability. Also, it can be used to develop technologies based on services that can be provided for fans or viewers. For example, we can use data from fans' preference and purchase history, and we can build a more automated system that can recommend the services that they might be interested in. As we can see, there is a very broad applicable area of big data analysis. Now I will explain the fundamental steps one need to take to start doing big data analysis for sports data. So the first step that needs to be taken is obviously we need to collect and categorize the data. The data for a big data analysis needs to be gathered from a reliable source. It can be through laboratory experiments, getting data from game statistics, or even surveys. The data also needs to be properly categorized or labeled for easy use when we further use it further down the line for analysis. The second step would be filtering and cleaning. So when we collect a large volume of data, there are typically noise or there are a few missing values. So the missing data needs to be removed and a proper filtering algorithm needs to be used so we can remove any noise that might end up impacting our results. We also need to remove any outliers, which are very extreme values that stand out greatly, as you can see from the figure, or are at an abnormal distance from the rest of the data. These can corrupt the data sets, altering the overall shape of the data and leading to any misinterpretation of very large data sets. The final step is obviously analysis. For sports data, we can conduct two different types of analysis. We can perform exploratory analysis, which means first would be either just getting the description of the data. For example, we can take out average values or variability, how far the data set is spread. And we can also see how the performance records are grouped together and classify them to find performance traits of different groups. Now, another form of analysis would be predictive. That is, we use pre-existing data and we can build models, be it be normal linear regression or very complex machine learning models that can predict any future changes in these values. This can be very useful when you want to predict how the performance will change for different types of sports activities. Although using descriptive analysis can be useful to summarize the data, to make any sense or make any inferences, we need to do classification and prediction. To do so, we might take two analysis approaches. First, it's linear analysis. This analysis assumes that the relationship between any two variables is linear, which means that any change in one of the variables would lead to proportional change in another variable. What does that mean? So how can we model this? So we can model this using a straight line that can best fit the data structure as seen in the figure. Now, another approach we can take is nonlinear analysis. This analysis assumes that the structure of the data is such that the change in one variables would not necessarily lead to proportional change in another variable. So to define the relationship between the two variables, we would use different type of curves that are not linear or straight line. Now I will show using examples how these approaches can be used for big data analysis, specifically for sports data. First, I'll talk about how linear analysis approach can be used for big data analysis. The most traditional form of big data analysis is the linear regression. Let us assume, so what actually is linear regression? Let us assume that we have performance records that changes over time. Here we want to understand the changes in the performance records over time using linear regression by first defining a straight line. So we draw a line such that the overall distance from all the data points is at a minimum. Then the line is defined by the equation where B0 is the slope of the line and B1 is the slope of the line and B0 is distance from its intercept. Now the effectiveness of the regression can be quantified using coefficient of determination, which is how well the line can replicate the relationship between these two variables, time and performance records. Now the value of r square ranges from 0 to 1, where 0 means none of the relationship can be replicated, while 1 means 100% all the relationship can be replicated. Now let me take an example from a study that I have performed. The graphs on the right show that the changes in the speed and time records of 446 master level decathlon athletes. Decathlon means they play 10 different sports. A single person plays 10 different sports. And these athletes are between the ages of 20 to 70. And I have taken the running records from 100 meter, 400 meter, and 1500 meter races. Here, as you can see, using a linear regression, we can define how the performance changes over with increase in A's, as how the performance changes with A's. How does aging affect performance? From this analysis, we find that as athletes get older, their speed decreases and the time to complete the races increases. So this analysis shows that aging leads to general decline in the performance of athletes. However, let's talk about other analysis technique to find any deeper insight into changes in performance. I'm particularly interested in motor abilities of athletes. Based on different energy pathways used by athletes during the 100 meter, 400 meter, and 1500 meter races, we can see that 100 meter signifies more of a strength or speed motor ability, and 1500 meter uses endurance motor ability, whereas 400 meter is a combination of both. We can see that from this Venn diagram as well. The 100 meter uses more of strength and speed, and 1500 meter uses endurance motor ability, while in the middle, 400 uses a part of both. So why would one want to understand and quantify the dominance of motor abilities? First, as we know, declines in the dominance of strength can lead to frailty and performance overall decline in the sports performance. So if we understand where there is a shift of dominance from strength to endurance, can help us design age-matched training programs to maintain strength of master level athletes or athletes that are old. This can be further expanded to even designing training programs for elderly and people with neuromuscular diseases who have similar loss in the dominance of strength motor abilities. And this can be used to enhance their living standard so that they can live a very healthier lifestyle. Also, we can provide guidelines to develop policies to tackle health disparity due to changes in motor ability dominance of people of specific communities or countries. And we can encourage them to increase the sports participation, and so that they can live a much more healthier lifestyle. No, so what are the traditional method of analyzing the strength and endurance motor ability? What we use is we use muscle biopsy to check the number and size of the muscle fibers. The type 2 fiber indicates strength and speed motor ability, amount of type 2 fiber, and type 1 fiber indicates amount of endurance motor ability. So the muscle biopsy process actually requires us to take out this muscle and then analyze the amount of fibers in those muscles. Now, as you can see, this method has certain drawbacks, right? So first, it can be, since we are taking out muscles, it can be quite invasive and painful. And it is a very long process, and it is time consuming as well. And it is very difficult and expensive to perform when you want to use this technique for a very large population, especially for normal general population. And the muscle taken out is from a single muscle, so that it might not be generalizable for overall body's muscular structure or muscle fibers in rest of the muscles. So to overcome these drawbacks, I will show you how we can use big data analysis to evaluate the dominance of motor abilities. Here I provide a solution in the form of principal component analysis, or PCA. I'll be using PCA moving forward. So this is a factor analysis technique, or a form of machine learning algorithm for classifying very large data sets. Now, how how can we use this technique to evaluate the dominance of motor abilities using performance records of running events. Let us assume that we have running records from a number of athletes, running records from 100 meter and 1500 meter from a number of athletes. And what PCA does is, first, it takes a line that explains most of the variance or most of the information from the data. That means the distance from most of the point is minimum. So this PC1, principal component 1, PC1, is the most dominant feature. It explains most of the data. Then what it does is it selects another line that is perpendicular line, that is completely independent from the first PC. It selects the line, such it draws the line such that it explains the next most information from the data set. Then the PC2 would be the second most dominant feature. Now, then we can determine how much the performance records from each events are correlated to each feature, which is also called factor loading. In this example, let us say 100 meter has a strong correlation with the first PC, down to 0.9, which means that the feature that explains most of the information from overall data distribution is mostly correlated to the strength motor ability, making strength the most dominant motor ability for this athlete data. Now let us apply this method on our previous data set. This includes 404 running data for 446 masters decathletes, and apply the PCA to evaluate how the dominance of the motor ability changes. First, what we did was we divided the data sets into group of 5 years, and we applied PCA. And then we found that till the age of 50s, 100 meter and 400 meter were strongly correlated with the most dominant feature, PC1. Making strength, this implies that the strength motor ability is dominant till the age of 50. After 50 years, we can see that 400 and 1500 meter is where correlated higher to the most dominant feature, the PC1. This indicates that after 50, endurance becomes the most dominant motor ability. We can see that in the figure on the right, where the factor loadings, or the correlation strength, is plotted against age groups. We find a clear flip in the dominance of motor abilities at the age of 50. So we developed a method that can quantify the dominance of motor abilities using very simple performance records. So this method, as you can see, can be applied to large population, is not invasive or painful, and can be done by openly available data. So this overcomes drawbacks of previous method. All is well, all this is fine, but we also want to know the next thing that I was curious about was, would I be able to apply this for general population? So this was for athletes from very specific events. So we applied the method for general population. So to do so, we acquired performance records from physical fitness tests from the Korean National Physical Fitness Survey. It's conducted every 2 years. So we took the data of 7,402 South Korean citizens between the ages of 20 and 65. So they recorded the grip strength, which is considered the muscular strength motor ability, then 50-meter dash, running 50 meters as fast as possible, which is considered as speed motor ability. Then there were sit-ups, which is considered for the muscular endurance motor ability, and pacer pacer means running back and forth 20 meters until at increasing speeds until exhaustion, which is considered the aerobic endurance motor ability. Now, dividing them again in 5-year groups, we performed linear regression. What we found was there was a general linear decline in the performance due to aging, but the coefficient of determination, the R square, was quite low. The highest we found was around 0.23 for speeds. So there is a general decline, but linear regression might not be able to completely replicate the data. Now, what we did was we applied PCA to the same data set, and it showed a different perspective by allowing us to see how the dominance of motor ability changes with age. It showed that the muscular strength and speed were dominant, followed by muscular endurance, then the aerobic endurance till the 40s. After which, till the 60s, aerobic endurance became the second most dominant motor ability. And after 60s, the most dominant motor ability became the speed and aerobic endurance. Hence, we show that using records of physical fitness tests, which are very easy to conduct, and applying principal component analysis, we can quantify the changes. We can see how the dominance of motor ability changes even for general population. Now, moving on, I would like to talk about nonlinear approaches for big data analysis with example research showing how it can have better effectiveness for, especially for predictive analysis. So to do so, first I would like to define an example goal for predictive analysis. Let's set the goal as developing a simple, accurate, and cost-effective model to estimate the body composition, which is the amount of fat and muscle mass in our body. As we know, maintaining adequate amount of fat and muscle mass is quite important. We need to be fit and we need to have enough muscles to generate force so that the athletes can perform at an elite level. Another thing is, if we have a lot of fat, if we are obese, there is an increase in the probability of mortality or an early death due to diseases that are common for obesity. Actually, in previous researches, they found that if you have a very high fat mass or very low or very high muscle mass, there is an increase in the risk of early death. So when you have a lot of fat in our body, we end up we become vulnerable to different diseases, cardiovascular diseases or neuromuscular diseases, and these kind of diseases can lead to an early death. How do we measure the fat mass and muscle mass? So typically body composition is measured using imaging equipment such as DEXA or an MRI. I think most of us are quite familiar with these kind of equipment. However, these equipment are quite costly, requires skilled technicians, that means people who are trained to use the machine, and it's very difficult to set up in areas with limited accessibility. We cannot take this big equipment to very remote areas. And it also requires a very large space. Now, here I will show how big data analysis, especially nonlinear approach, can be used to estimate accurate and cost-effective model that can be used to estimate the body composition, that is the fat and the muscle mass. Actually, in the past, very simple and cost-effective model using linear regression approach has been used. This was done by acquiring the demographic data, such as gender, height, gender, age, and ethnicity, and anthropometry, that is the body measure, such as height, weight, limb length, and circumference of different parts of the body, and skin fold thickness. These data were related with the body composition obtained from expensive equipment to build an estimation model. A multiple linear regression model is built using this data, which has muscle as the predicting variable, which is this method is similar to simple regression. We just have a lot of predictors. Actually, previous studies found that this linear model worked quite well. It had relatively high R-square values from 0.7 to 0.9. But most of the data was used for very specific population, and the number of people used to build the models was quite low. Also, very important drawback, or very detrimental drawback, was that so as we increase the number of inputs, there is a chances of nonlinear interaction between even the input variables, that is the predictors, like gender, age, ethnicity, these are the predictors. And also model iteration is not possible. That means linear regression linear analysis has no framework that allows us to find the best relationship between that can minimize the error between the estimation and the actual values. So the estimation values using the model and actual values that we got from the very expensive equipment. This can help us to further refine the model and increase the accuracy. So how did we solve this? So a possible solution is using artificial neural networks, or ANN. This method simulates the learning behavior of a brain. In our brain, we have neurons that constantly interact with the outside environment and builds a model so that we can learn, adapt, and make very accurate decisions. And in the meanwhile, we try to reduce any form of error, any form of mistakes. The ANN, artificial neural network, uses the similar concept and builds a hidden layer that acts as a neuron in the brain and consists of various nonlinear functions that interact with the input and output to find best possible solution to minimize the error between the two. Hence, we can do model iteration. So, artificial neural network is also a deep learning method. So we checked if an artificial neural network could perform better at estimating muscle and fat mass. So as I specified in previous studies, the sample size was quite low. So what we did was we acquired a very large data set from more than 20,000 US citizens from the National Health and Nutrition Examination Service, NHANES. So even you guys can go and download the data set. So the data consisted of demographics, like I said, age, height, weight, and body measure. Demographics such as age, gender, ethnicity, and body measures, height, weight, limb circumference, skin fold thickness, from a very wide range of population. They have of different age groups, ethnicity. So our model can be a much more generalizable model that can be used for different populations. So what we did was we first created the multiple regression model, like I explained before, and then we compared it with the artificial neural network model that we built ourselves. What was the difference between the linear model and ANN model? So we found that the nonlinear ANN model performs better than the linear regression model. Here we can see that the R-square values was significantly higher for ANN model. If you look at the graph on the left, and it's very close to 1. That means it could replicate most of the data. And also the error estimate. This is the difference between the data from the DEXA and the data acquired using our model. This was significantly smaller, so we have reduced error when we use the ANN model. This shows that the nonlinear model can have better estimation of body composition using data that can be simply acquired, such as demographics and body measures. So this can be applied in areas that are remote for very large population. We also published this study, these results of this study this year. It's right there on the lower side of the slide. You guys can check it out if you want more details. So before I end the lecture, in this last slide, I want to talk about the prospects of big data analysis in sports. Actually, it's quite bright. It is shown that the global market of sports data analytics will continue to grow, which means that there is a lot of opportunities to work for students and researchers or other professionals. So to prepare them to work in this expanding market, I want to encourage the students to focus their education in very few key areas. These include sports science. So sports science means sports biomechanics, sports medicine, sports physiology, sports psychology, and even sports management. And then they also need to focus on mathematics, background behind building the different models, and statistics as well. And the next step would be program. So you need to learn to program. You can use Python, MATLAB, or any other form of programs that you like. And another very important thing is, since there is a very large amount of open source data available everywhere, it gives us a lot of opportunities to practice and to build up our skills and become a effective sports data analysis. So I want to encourage you guys to go out, find different data sets, and try performing big data analysis using different form of sports data or any other kind of data. So more you practice, the better you're going to be at it. With this, I want to end my lecture today, and thank you all for your attention.